Our next presenter is exploring emotion sensing algorithms to improve how we interact with our computers and our content. CEO of Affectiva, Rana el Kaliouby.
Good morning, everyone. Pleasure to be here today. So I'm going to talk about how we're humanizing technology through artificial emotional intelligence. The picture here is of my son practicing how to make different facial expressions. He's actually here in the audience today. So I have a bold vision. I imagine a world where we interact with technology just the way we as humans interact with one another. Through conversation, through perception, through facial expressions, through tone of voice, through gestures. Whether it's an app on your phone or a social robot friend in your home or your car or Amazon Alexa, I imagine a world where our technology is emotion aware. Just like the movies. How many people have seen Her and/or Ex Machina? Show of hands. Quite a bit. There's this one particular scene in Her that I find truly fascinating. So Theodore is this guy, he's super depressed, he's in bed, he can't get out. And Samantha, the new operating system, knows him so well that she's able to persuade him to get out of bed, and they spend a day at a beach, and it's awesome. Now, of course, this is the movie's world, and the movie takes a dark turn. But what I find truly interesting is this idea that because this operating system knows him so well, she's able to persuade him to change his behavior. And therein, I think this is the opportunity and the potential of emotion AI. It's this idea that because technology can know you so well, it can persuade you to change your behavior in positive ways. So I started on this path over 17 years ago now. I grew up in Cairo in the Middle East, and I was studying computer science. I was particularly interested in how we interface with computers and how computers change the way we communicate with one another. And then I had this opportunity to do my PhD at Cambridge University. This was my first living abroad experience. And when I got to Cambridge, thousands of miles away from home, I realized I was spending more time on my laptop than I did with any other human being, which is sad. But I don't think I'm the only one who does that. And I also realized that this computer had absolutely no clue how I was feeling. There were days when I was stressed out, I had an upcoming deadline, and it was just totally oblivious to my emotional state. I also realized that it was my main portal of communication to my family back home, and there were days when I was very, very homesick, sometimes even lonely, sometimes even in tears, and this was the only thing I could communicate. And it didn't even look that fancy, right? So emotions matter. We know from years of research that when it comes to shaping our decisions, often our feelings count, as much as, not even, sometimes even more than our thought. So IQ and EQ go hand in hand. But in the technology world, the way we interface with technology is on its own it's on its own language, not ours. Its own terms, not us, not our terms. So all very unnatural ways for humans to interact. And even as we move into a world where interfaces are conversational, 20% of mobile queries are now voice-based, these devices have a lot of smart but no heart, lots of cognitive intelligence but no emotional intelligence. If we think of Amazon Alexa, which is one example of a conversational interface, it is designed to be very transactional today. It's not really conversational. You ask it, what's the weather? It answers back. You ask it to play a song, it does that for you. But there's no back and forth. And in fact, there was this recent article, which I find very interesting in CNN Money, about how people rage against these new interfaces like Cortana and Siri and Alexa. Often using really, hateful words against these interfaces because they're very frustrating. And they're very frustrating because they are emotion blind. And so Alexa has a team that is primarily focused on solving this emotion problem and building empathy into Alexa because they realize that if it's empathetic, you're going to want to spend more time with it, which is what they want. Now, what motivates me about this research is not just human-computer interactions. It's because I believe that this is affecting human-to-human communication. It's not surprising that even though we feel more connected to each other than ever, we actually feel a lot more lonelier. And there's this one particular example, I don't know how many of you have seen this one. 4 teenagers, I think this was like last month, they videoed on their phone a person drowning. So they see this guy, he's clearly drowning, he needs help. They don't think to call for help, they don't think to call for police, and they just sit there and film him. And you can hear them towards the end saying, "Oh, he just died," and they laugh. Whatever happened to human empathy? You know, there's a school of thought that says, well, we need to do away with our technology, but I think that that's not practical. It's expected that we're each going to have about 6.5 devices, personal devices, by the year 2020 on average. And I look at my 2 kids, and I just don't see them doing away with technology. So instead, I've devoted my entire career, first in academia and now running a company, to develop technology that could identify human emotions just as we can. You know, what if computers could tell the difference between a smile and a smirk, laughter and frustration? And what if technology could augment our emotional intelligence the way we can augment other physical abilities? What's the equivalent of a hearing aid or a prosthetic leg or an visual implant in the social emotional world? And what would that look like, especially in an online digital world where I believe our EQ is a lot lower because we're missing all these nonverbal cues that are really critical in human-to-human connection. One of the first applications I explored at MIT was building wearable devices for individuals on the autism spectrum. So autistic people really struggle with reading and understanding nonverbal cues. So we built these, this was way before Google Glass, so we built these glasses that had cameras, they pointed out, and they analyzed your facial expressions in real time and gave you feedback. We piloted that with a partner school in Rhode Island, and we were able to show that the kids learned to, they did more eye contact, more face contact. And now we're partnered with a company called BrainPower that is commercializing this, actually using Google Glass as the platform. But it's not just autism. The applications of emotion AI are very broad, everything from media and advertising to gaming to education to healthcare, and I'll touch upon some of these applications in a bit. But first, how does this work? So we as humans communicate emotions through a number of ways, everything from your tone of voice, your gestures, your physiology, and your facial expressions. The science of facial expressions has been around for over 200 years. It first started with this guy called Duchenne, who used to electrically stimulate your facial muscles to study it. And that was pretty painful. We do not do that anymore. And then in the 70s, Paul Ekman and his team published the facial action coding system, which is a method for mapping each of our 45 facial muscles into a code. So I'll give you a few examples. Action unit 12 is the lip corner pull. It's what you activate when you smile. You can try it. Action unit 4 is the brow furrow, which is the corrugator muscle, which is an indicator of a negative expression. And it takes about 100 hours of training to become a certified fax coder or a face reader, and then about 5 minutes of time to code every minute of video. So it's very laborious, not scalable, time-intensive process. And what we do instead is we use computer vision and machine learning to automate this process. And so I'm going to attempt a live demo. Let's see if we can I have a volunteer? Volunteer, do we have somebody volunteer? I can't see. All right, Mike. Ooh. Yeah. Awesome. All right, so let's give this a try. Do you want to hold the iPad?
Sure.
All right. So you'll see that it's recognized Mike's face right away. It's locked onto his face. It's also identified his gender as male. And now it's going to start kind of reading your facial expressions. So actually hold it a little bit like that. Yeah, that's better. All right, so start with your poker face. Awesome. And then, oh, you have a good poker face. And then let's test the computer. Let's see how well it does. So start with joy, which tends to be okay, there you go. Brow raise, look surprised. Kind of. How about a nose wrinkle, like look really disgusted? There you go. Brow furrow, like confused? Like what would you look like if you were confused? Yeah, yeah. How about like you blow a kiss? There you And then stick your tongue out, and then there you go. Awesome. Thank you. Thank you. So basically, this technology can read your facial expressions in real time. I'm showing here an example of it processing a movie trailer just to give you a flavor of where the different scenarios where this technology can be deployed. So you can see here there's a number of different faces, different profiles, different ages, genders, ethnicities. There's often a crowd. So you can imagine how this can be applied to a crowd like this in stadiums and arenas, but also maybe in hospital rooms, looking at surgeons and patient interactions, meeting interactions, maybe classrooms. The same type of technology can be applied in a number of places. How do we do all this? We use deep learning to train convolutional neural nets to recognize these different expressions. So we feed it, in our latest training examples, we've been feeding it about millions of images of people doing lots of different expressions. We feed that to the neural nets. We play around with the size of the neural nets, the depth of it, and the different parameters, and also data sampling. And so far, it's able to read about 20 different facial expressions. Some of it are obvious, like a smile or a brow furrow, but some of it is quite hard, like a squint or a smirk. We also are able to read 7 different emotions: valence, engagement, age, gender, and ethnicity. Through our work with our partners around the world, we've amassed the world's largest emotion data repository, 5.5 million faces in 87 countries, which is about 2 billion facial frames. And it allows us for the first time ever to ask questions like, who's more expressive, women or men? And it turns out women are more expressive than men. No surprise there. But it does depend on cultures. So in the US, women tend to be more expressive than men, but in the UK, there's no difference between men and women, for instance. Some of the challenges we're addressing in kind of the core technology, multimodal, so humans read emotions and express emotions using different channels. We're now starting to combine facial expressions with voice analytics. We have way more data than we have labeled, so we're exploring unsupervised learning approaches on how to leverage a lot of the data we've collected. We're interested in real-time applications, so model compression and running it on device like I showed you, that's a key research area for us. And then expanding the repertoire of emotions that the computer can read. Right now, I kind of liken it to a toddler in terms of the different emotional states it can recognize, so there's a lot more to do. About a year and a half ago, actually a little bit more, we decided to package the core engine as SDKs that run on a number of platforms because we recognized that there's a lot of real-time applications out there, and we didn't want app developers to spend a lot of time reinventing the wheel, so we wanted to package this up, and we like to say you can emotion enable your device or your application or your digital experience in under a day, as opposed to spending years replicating a lot of this work. So what are people doing with this? Some of the applications: redefining how we engage with content. 1/3 of the Fortune Global 100 companies use our technology to understand how people respond to content. And then if you take that step further, you can imagine how we can personalize experiences using this technology.
You see, with emotionally intelligent technology, interfaces are replaced with faces. What if 2 people had entirely different experiences watching the same content, all based on how they felt? That's where responsive media comes in. For example, let's say a whole family loves mysteries, but Dad is really grossed out by all the blood. Mom loves it. Hal likes all the romantic scenes, even though he says he doesn't. So Dad's version is a little light on the blood and heavier on the comedy. Mom's is a complete bloodbath, and Hal's is a sweeping love story.
And so in that world, what if our entertainment could react to our emotions in real time? What if a story could be personalized based on how you're feeling? And I think that creates an entire new industry, really, for incorporating emotions into your digital experience.
And from entertainment and gaming, automotive. Automotive is a space that's being disrupted very, very quickly, and we're being brought in to understand driver state. So what if your car knew that you were getting angry and the brakes could respond adaptively? Or in a semi-autonomous world where the car is in control, but sometimes it needs to relinquish control back to a driver. It needs to know if the driver is awake, paying attention or not. And so there's a lot of interest in understanding the occupants and drivers and co-pilot states using this type of technology. And if you broaden it a little bit, what if every device in the Internet of Things could could understand your mood and make personalized suggestions? One of my favorite examples is, imagine if your fridge knew that you were stressed and about to binge eat and eat this extra tub of ice cream, and it locked down. Didn't allow you to do that. That would be helpful, I think. Although I think people would learn how to hack it. But, one of the applications that really excites me about this work is the potential to democratize access to education and health. So imagine in a world where students around the world do not have access to an amazing teacher or amazing schools and classrooms. What if they had a learning app that could understand their learning style and their level of engagement and adapt in real time? This is happening. We're partnered with a company in Hong Kong that is building applications like this. Tega is a social robot built at MIT Media Lab, and they, again, integrated our technology as the emotion brain of the robot, and they were able to demonstrate that the emotionally responsive learning companion, Tega, helped the kids learn Spanish words faster, and they were more engaged and less likely to quit. In health, what if doctors, whether it's a human doctor or an AI doctor, what if they could understand your mental health and how you're feeling objectively, the way they do with other vital signs? When you walk into a doctor's office today, you don't ask the doctor doesn't ask you what your blood pressure is, they just measure it. Yet in the space of mental health, you still have a pain scale from 1 to 10, like how much pain are you in, or how depressed are you, or how suicidal are you? And it's very, very subjective, unreliable data, and I think we can do better. We are collaborating with a professor at UMass Boston, Stephen Vinoy, who imagines this world where your phone can act as a sensor, as an emotion sensor. It can understand your baseline, and it knows when you deviate from that baseline, and it flags that to a clinician or a partner or a family member. At USC, this team built Ellie. It's a digital avatar. It diagnoses and tracks depression using body movements and facial expressions. And they found that patients were more likely to open up to Ellie than they did to doctors. And I think that that's fascinating because doctors tend to be more judgmental. And I believe that opens a lot of questions around ethics and morality and the blurry line between how much do we want to allow machines to be like humans? And there's definitely potential for abuse, like with any technology, but I think the potential for good far outweighs the potential for abuse. And I think it's our responsibility as a team and as thought leaders in this space to challenge the rules and to involve the public in defining these guidelines. We're putting together a summit in September at MIT Media Lab where we're doing exactly that. We're inviting people to discuss the future of emotion AI. What kind of applications are we comfortable with? What other applications are we not? What are the guidelines for how an AI doctor could share or not share your personal data? How much autonomy do these things have? But fundamentally, I believe that emotion AI is the next frontier of artificial intelligence, and it allows us this opportunity to redefine how we both engage with technology, but also ultimately connect with one another. Thank you.